We are now going to talk about cloud security. And cloud security is a topic that is definitely growing in importance since there are so many more people who are actually using cloud accounts and cloud computing in their daily work. And one of the interesting things is how many more people are using it in the Fortune 500. And what that means, of course, is that there is now big business being conducted on the cloud. And the reason for the appeal of it is the scalable computing resources that are available on the cloud, meaning that there's less activity of typical IT nature around scalable computing resources, which would involve more of dedicated teams who have to, during high utilization times, get more servers built out and spun up and more resources that connect to the servers, so the whole network infrastructure, and more people would have to shift their daily responsibilities during a peak time, like suppose Black Friday, to their support. And so having cloud that allows you to do a lot of these things by default and sort of automatically allows corporations to really plan around their workloads or their utilization of resources in a different way. There's different things that are available on clouds. There are so many new services that are always coming up, like artificial intelligence and batch processing, web hosting, all kinds of add-ons to traditional business support. And there's automated call centers. There are integrations with the Internet of Things. And every day, more and more things are being available that no longer have to be hosted or installed and maintained on premise for a company. And that's one of the big appeals of something that's cloud-based, is that, of course, there are internal clouds and hybrid clouds, but the public clouds, meaning the companies that host the cloud for you, are growing in popularity, and that's the direction where the world is going. And they're externally hosted, which of course presents a new security challenge where if you have data and services which now live outside of the perimeter of your data center and aren't physically under your control, how does security look in that world? And the other big thing is that for cloud, the company, for example, Amazon or Google or Microsoft or many of the smaller players in the cloud provider world, they are only responsible for part of the security. What happens inside the account once you set up a cloud account and you spin up your computing resources in the cloud and your network infrastructure, that is your responsibility as the client. And those companies are not responsible for setting things up wrong and allowing intrusions and breaches to happen. So why would cloud be such an appealing target for the attackers? Well, as I was saying, a lot of the Fortune 500 are moving over there, and those who aren't there yet are planning to go over there soon. And so there's going to be a lot of valuable systems and information that is going to be the target of attacks for years to come, because more and more data centers are getting closed down and the cloud, especially the large providers, are becoming bigger targets. And we are going to see the type of attacks as well as the frequency of attacks increase. And that is something that needs to be taken into consideration today already, because as new systems are being built out, this needs to be taken into account as part of the problem, that anything that is built for current systems and current volumes is just not going to work for when there are more attacks that are focused solely on the cloud. One of the reasons why the attacks happen is for cryptocurrency mining. And if you're familiar with cryptocurrency, you know that there's a lot of computing resources that are utilized in mining new coins in cryptocurrency. And that actually is also why there's always people who are looking for new computing resources they can use cheaply. And one of the ideas that people have is to compromise cloud computing resources and essentially create botnets out of somebody else's cloud resources and use those for mining things like Bitcoin and sending it back to the botnet controller. Another reason is data. Data is like gold, as we talked about in the world today. And a lot of data that companies are moving as they're moving to the cloud is less secure. And because of this, people see this as an opportunity. The attackers see this as an opportunity before the cloud customers catch up with technologies that are used on the cloud to the level that they have with technologies used inside internal data centers, that there is a moment where data might be overexposed. And that's what a lot of attacks are motivated by. This is why identity and access management is even more important on the cloud. We need to have a more restricted set of users who are able to perform activities in the cloud compared to having all of our employees be users if we have a company that has information systems of its own. And we usually allow all users to have an account of some sort or other, whether it's intranet or just for their own laptops. And not everyone needs to have access to our cloud infrastructure, especially if their roles aren't related to performing operations in the cloud. And even those users who are in there need to have a very granular set of roles. And what we need to do is separate admin activities, super admin activities, root user activities, simple user, support user, power user. We can really stratify our roles and authorization system and make sure that only users who need to have certain capacities have them. And sometimes the best way to do that is to follow a Linux and Unix system where certain actions have to be done as a admin or root user, and a normal user would have to access that by assuming that role. And we can keep track record of that. That way we can see which user has assumed admin privileges for what purpose. And that lets us have an audit trail and also gives us more control on who is allowed to perform certain actions, since we are keeping track of the role instead of specific users. And then we're just keeping track of what users are allowed to assume that role. And we also want to have a lot of detailed policies around access to specific resources. And those policies can be mapped to either specific users, which I feel like is not so scalable, or we can have roles. And roles can be seen as groups of policies where the access to a particular kind of resource, like suppose text files inside S3 buckets, that kind of policy can be grouped under somebody whose role is as a data engineer. And then they're also allowed to access some of the MapReduce related Amazon services, but perhaps they're not allowed to use some of the tools that are around the gaming platform or the IoT platform. And some of the measures and techniques that we can use to secure cloud are network access controls, so that the cloud resources are not available publicly by default, so that perhaps we can only access them from our own network or from a restricted set of other resources like jump hosts or special access servers. And we also want to make sure that logging and monitoring is turned on so that we have a thorough trail of access to cloud resources and who is doing what when. We can see when certain activities are running, when certain jobs are running, what kind of IP addresses are being connected from, what kind of payloads are getting delivered to our services, what is being asked of our cloud resources, and whether it matches our expectations of the workload. And we can also set up alerting based on that, where if there's overutilization of resources, we can get them shut down, we can get an alert, and we can see whether this is legal or illegal activity. And we can also not worry about getting huge bills, because one of the things is, because cloud computing is usage-based, so essentially the more of the resources you use, the more you pay. If you have an attacker come in and use your cloud resources, you might be the one who is stuck with the bill, unless you can show that you've taken appropriate measures to try and defend against this and there was still a breach. And This is an important aspect of the whole cloud picture, which is the financial aspect. And we need to make sure that when we are using the cloud, especially scalable cloud resources, we have an idea of how much it's going to cost us, and we have an eye on how much the projected spend is. And something like cyber attacks, where somebody is utilizing our cloud resources, can definitely change that number. And so even keeping a track of the bill is going to help us figure out whether we are being attacked or not, even if sometimes there's other metrics which won't tell it to us, at least not directly. And this is where automation comes in as well, where we want to have our alerting be connected to automation, where perhaps if we have a bad actor, a user who is performing actions they're not supposed to, these can be detected via alerts and monitoring, and we can automatically disable their access, or at least put it on hold or lock it up. And these kind of monitoring and alerting tools connected to automation can be the solution to how do we support something that is so scalable, where we used to have perhaps a limited dedicated support team for our usual security operations, but as the number of servers we own in the cloud grow, how can we perform the same tasks with a smaller team? And the idea is that we wouldn't. We just have automation take care of a lot of the routine tasks for us, and especially something being available 24/7 definitely beats having to have a team on rotation monitoring alerts constantly by hand.